Okay, hello everyone, hi and good evening people. I welcome you all to the platform of Sri Chaitanya. My name is Shubhajit everyone and I'm an educator of physics. Okay, so I welcome you all to the platform of Infinite Sri Chaitanya. Now the people, as you all people know, that we have started we have started a scholarship test. Okay, and since from past 2 days you will be you are being informed about that there are a lot of things which are going on in our today's session. Why this particular session is very much important, since in that particular score examination or the score test that is going to be happen, we have given a lot of things. Okay, we have announced a lot of things that we will be preparing you about the test, how to give the test. We will be also giving you all the information, all the knowledge and every single thing which is related to the subject. So today we will be having a session on the physics. Okay, so today we will be having this session on physics for the grade 9 and grade 10 students. Fine, but before that, let us talk about little bit more about the score examination. As you people all know that it is completely detailed, it is there. Okay, you have been the part of the score event, but still few information everyone. As you people know that the score is going to be the India's very big, the biggest scholarship test. It is going to be happen for the grade 3 to grade 12 student. Okay, as well as you can see, you all people will be having 2.5 crore of cashbacks and 350 crores of scholarship test. Including with this, there will be a NASA trip and exciting gadgets. Okay, and up to 100% of scholarship if you want to, if you have if you've been selected to, and if you want to be the part of Sri Chaitanya. Fine. Moving next, as you all people know, this is what we as in Sri Chaitanya is offering. Okay, NASA trip, then we have cash rewards, then we have the gadgets, then we have the scholarships and all. Fine. So I request all of these students, okay, let us have a try, let do a try. You people are very smart, you people know how to solve the questions and all. Okay, so why not to give the examinations? Why not to give the examination? So you can go to the score Sri Chaitanya website where you can register entire thing. Okay, start registration, fill the form, pay the fee. I believe the fee is around 150. Okay, you can pay it, and the examination will be online and offline both. Okay, so that is also a very advantage of that. Fine. So the examination date will be between 28 September to 12 October. So start registration everyone, and you can register on the website, that is Sri Chaitanya. Now, as you can see in the screen everyone, as I've told you earlier also that I take care of physics. Okay, I take care of physics for grade 9 and grade 10. Fine. So as you can see, this is the syllabus for the score examination. If you are the student of grade 9 and you want to give the score examination, fine. So what is the syllabus? Syllabus is motion, Newton's law of motion, electric current, gravitation, work and energy, friction, and the pressure. So these are the chapters that you have to prepare for giving the examination of the score if you are in grade 9. If you people are in grade 10, then the chapter that you have to prepare for is the light, electricity, magnetic effect due to current, motion, gravitation, and work and energy. This is the syllabus for the preparation of the score examination everyone. Fine. Now in our today's session, we cannot cover every single thing, as you people can see. Okay, Durgesh, this is the class for the score examination. Score examination is a scholarship test that Sri Chaitanya is offering. Okay, and the class is running on for the preparation of that particular score test. Okay, so as you people know that we cannot do the entire chapters in 1 hour or in one session, obviously. Okay, so what I am going to do is, as you can see, let us target grade 10. Okay, let us target the grade 10, and you can see there are the portion that is common to the grade 9 also and grade 10 also. The portion are motion, gravitation, and energy, work, energy, and power. Okay, so we will be completing this particular 3 chapters. I'll try to give my very short answer, okay, and the great explanation, so that it will be very helpful to solve you the questions, whatever the question that you are going to face in the examination everyone, the score examination. Fine. So today we will be having an understanding of the chapter motion, gravitation, as well as the work, energy, and power. Fine. So it is going to be a very exciting session. It is going to be very crisp, very brief. Okay, whatever it is important, I will be explaining every single thing. Okay, as well as the formula will be also written to you. So let us start with the motion part, everyone. I believe right now, if you are people are in grade 9, you might have started the chapter motion. Okay, you might have started the chapter motion. Now, in the chapter motion, there are a lot of things that you have to take care of. There are few theories, okay, there are few concepts on which the numerical is going to be asked, okay. There are few concepts which are in the form of a theory, but still the question has been asked on that particular topic. Now, when we talk about the motion chapter, everyone, what are the things that is very much important to you? I won't be writing every single thing, okay. I will be explaining few of the theoretical things. Then the important part which I want to write, I will be writing on the screen. In the motion chapter, everyone, that there are two different, there are concepts known as the rest and the motion, because we have to understand first of all what is rest. Then we have to understand what is motion. So what is rest and what is motion, that is very much important for this particular chapter to understand. But before this, you have to understand reference, everyone. Okay, reference. For an example, if you are saying to a particular object that this object is completely in rest, or you are saying this object is completely in motion, or moving from one point to another point, okay, how it is possible? Getting my point? So the word reference comes into this particular definition. When it comes to the definition, reference is very much important before giving an explanation whether that particular body is in motion or is in rest. What is reference, everyone? See, to give a statement ki, okay, this particular body is in motion or this particular body is in rest, you have to define that from which respect you are saying this. Getting my point? So to define the motion and the rest for a particular body, the reference that we all people take is the time. Whatever the answer that we are going to give, it will be given with respect of time. And the second reference that we are all people are doing, that is known as observation, everyone. Observer. Okay, for me, for an example, I am the observer. A particular instant is going on, a particular event is going on, and I want to know whether that particular event is, I want to give that particular answer for that event, that event is completely in motion or it is in completely rest. Getting my point? So how I will be giving the answer? So I will be giving the answer on the basis of time, on the reference of time, as well as on the basis of the observer. I am the observer. For me, that particular body is changing the position from one point to another point. It is moving. So I will be considering with respect of time, since it is moving from one point to another, I can say that particular body is in motion. If the body is not changing the position with respect to the time also and with respect to me also, then I'll say that body is completely in rest. Getting my point? So to define rest and motion, they both are relative, everyone. To be very specific, please do remember this. Rest and motion definition are very much relative. It totally depends on who is the observer, how it is looking, how that observer is looking to that particular event, as well as with respect of time, we have to give the answer. Okay, so if I want to define the rest, what is rest? So I will be defining it like this way. A body is considered to be in rest whenever that body is not changing its position with respect to time as well as with respect to an observer, then the body is considered to be in rest. If the body is changing its position from one point to another with respect of time and with respect to a observer, then we can say that particular body is in motion. Fine. So we have completed the rest part also. We have completed the motion part also. So I believe this much is clear to you. What is rest and what is motion? When we have defined about the rest and the motion, people, okay, there are few things that we have to define more. What we have to define when we have talk about the rest and the motion, the definition of the first thing that we are going to learn is known as distance and displacement, people. Okay, the first topic that we are going to cover in our today's session, it is going to be distance and displacement. Okay, two different terms, but the explanation is very much simple. I won't be writing much. Okay, I will be just giving you the information about the distance and the displacement, people. So let us talk about like this way. Okay, suppose that this is a point from where you want to start your journey, and this is the point where you have to end your journey. This is your initial point, this is your final point. Okay, and this is the path on which you have to move. Let us suppose this is the path This is the path on which you have to move. Getting my point? So you were in the initial position. You were there in your initial position and you have to reach your final position, that is point B. So this is the actual path on which you are going to travel from point A to point B, everyone. You are going to travel on this particular orange path, which is going to be an actual path, okay, to travel from the point A to point B. That is the actual path from the initial point to the final point. Getting my point? Now, if I ask you, can you measure this path? The answer is yes. You will be measuring this particular path in meters, kilometers, okay. You can measure it. Getting my point? But when we are going to measure this thing, we are getting a magnitude. For an example, like 25 kilometer, 200 kilometer, 250 meters, whatever the unit is, but it is the value that we are getting, the numbers we are getting. But if I ask you, by looking into this, are you able to see any specific direction? The answer is no. You cannot say that if we are moving in this particular orange path, which is the actual path for the movement, we cannot say that we are having a specific direction. That means whatever the physical quantity that we are talking about on this particular orange path, it is having a magnitude, but it is not having a direction, a specific direction. Getting my point? So that particular physical quantity, it will be a scalar quantity. Which physical quantity we are talking about, everyone? So when a body is changing its position from initial point to the final point by the help of the actual path, that is called as distance. Okay, that is called as distance, people. That is called as distance. Please do remember this. This thing is called as distance. This thing is called as distance. Please do remember. Okay, this is the actual path having only magnitude. You can measure it, but you don't have any type of any specific direction, and this is the actual path from the initial point to the final point that every single body can travel. This is called as distance. Now if I say that I have, if I say, like for an example, I won't take this particular path. What I say that I can fly from point A to point B. What if I can fly from point A to point B? If I am able to fly from point A to point B, then you can say that this is going to be a path. This is going to be a path which is completely, you can see the green dotted line, everyone. I'm just trying to show you a green dotted line, which is the shortest path with respect to the orange one. You can measure it. You can simply look into this, that the green dotted line is going to be a very shorter path with respect to the orange line. Getting my point? If you look into that green dotted line, which is from the position A to position B, from the initial point to the final position, you can see we can measure that also. You can measure the distance between A and B. As well as if you look clearly, you can see there it is having a specific direction also. So there is a path which is shortest to the actual path, as well as we can measure it. That means we can find out the magnitude, as well as it is having a specific direction. So whatever the physical quantity that we are talking about, it is going to be a vector quantity, everyone. It is going to be a vector quantity, and this physical quantity is known as displacement. This physical quantity is known as displacement. Fine. If you want to write few points about distance and displacement, so you can write few points, everyone. What are the points that you can write? First of all, there are few points that I want to write over here only. Distance is considered to be known as scalar quantity. Why it is known as scalar quantity? Because it is having only magnitude but not the direction. Second, if we talk about the SI unit of distance, it is going to be meter, as we all people know. When we talk about the displacement, everyone, okay, I'm writing something about the displacement in this side, or like this way. Okay, if we talk about the displacement is going to be a vector quantity. And one more thing, the SI unit of the displacement is meter only. Getting my point? So displacement is a vector quantity, but the SI unit is meter. Distance is called as the scalar quantity. Still it is going to be, the SI unit is going to be meter. There are a few more points about distance and the displacement. If you look into the picture very carefully, you can clearly understand that the magnitude of the distance, will be always greater than, or there is one situation where it is equals to displacement, everyone. Okay, so please do remember that the distance will be completely greater than in the magnitude with respect to the displacement. It will be always greater. There is only one situation in which distance and displacement can be equal. What is that situation? Situation is if the body moves in straight path. If the body moves in a straight path, in that particular condition, please do remember this, that the magnitude of distance will be equals to the magnitude of displacement. The magnitude of distance will be equals to the magnitude of displacement. This is what it will be there. Fine. I believe this much is clear to you and you have understood about the distance as well as the displacement. Distance is the actual path on which the body is moving from initial point to the final point, whereas the displacement is the shortest path between the initial and the final point. Getting my point? I hope it is clear to all and you have understood this much. Fine. Whereas, as we know, the distance is a scalar quantity, so it can be positive and zero. When we talk about the displacement is a vector quantity. It will be negative, positive, and zero. Negative, positive, and zero. I hope this much is clear to you. Okay. Now the question arises how it is going to be zero. So let me help you out with one example, a very simple example. Suppose that this is a circular track. This is a circular track and you are running on this circular track. You have started your running from this particular point. So this is going to be your initial point, everyone. Suppose that you have started your journey running on the circular path, on the circular track from this point. And your final destination is also that point only. So we have defined the displacement is what? We have defined the displacement is going to be a shorter path between the initial point and the final point. If you look clearly, you can say the initial and the final points are same. For me, I am running on this circular path, so it is same. So in this particular condition, you can say that the displacement is going to be zero. Okay, if the initial and the final point of a body moving is same, then the displacement is going to be zero. I hope you people have understood this much, and this is what all about the distance and the displacement is. Fine. Now, moving next, people. I'm extremely sorry. Chalo. If it is so, and we have understood this much, what else is left it out over here is, since we have talked about distance and displacement, now we are going to talk about speed and velocity. Okay, now we are going to talk about speed and velocity, everyone. Now, sorry. Okay, we are going to talk about speed and velocity. I request you all to please just pay attention over here. Okay, so the next topic will be of speed and velocity. Chalo. Now, the first point we are talking about, we are going to talk about speed. Okay. Now, if I ask you, as I totally agree that I totally know that you have gone through this particular chapter, that is fine. But if I ask you what do you mean by speed, the first answer that is coming in your mind is, sir, speed is equals to distance by time. And which is not wrong, it is completely true. But I have asked you about the definition. I didn't ask you about the mathematical formula. Getting my point? So what is speed? Basically, so speed is a physical quantity which is helping you to find out the magnitude of a body, that how fast that body is moving or how slow that body is moving. Okay, speed is considered to be known as the physical quantity to find out, to measure the magnitude of a body of the movement, whether it is moving very fast. So how fast? 1, 2, 3, 4, 5, 7. What is this? The value is given by this particular physical quantity that is known as speed. Getting my point? There are few points about the speed that you have to understand over here. The first is the formula, of course. Okay, so when we talk about the speed, you all people know the formula. The speed is equals to distance by time. Distance by time. That is totally correct. There is no problem in this. Including with this, if we are moving forward, we want to know more about the speed. So the SI unit of speed is equal to, see, distance is meter, time is second, so it is meter per second. Simple. It is meter per second. Second point, speed is a scalar quantity. Please do remember this. Speed is a scalar quantity. It is not a vector quantity. In speed, we only are interested to find out the magnitude of the body, that how fast the body is moving or how slow the body is moving. We are just concentrated and we are just interested to find out the movement. That's it. We are not bothered about the direction. I hope it is clear to you. Now, when we talk about the speed, there is one more concept that is coming. When we talk about the speed, there is another concept that is coming in the speed, that is known as average speed. That is known as average speed, everyone. Average speed. Now, you can denote average speed by any method. Okay, so I used to write, I normally write average speed like this. That V average, okay, you can use anything. V average is equals to total distance by total time taken. Now you will be asking me, sir, if you look into this formula, this average velocity, average speed formula and speed formula, both look like same only. Because when we talk about the speed, it is distance by time. When we talk about average speed, it is also total distance by total time. What do you mean about this? What do you mean? What do you mean by this? So for an example, let us suppose we have to take this particular orange line for the finding out the speed. Suppose that I and you are traveling with a vehicle, okay, and I have taken this path. I haven't stopped for a second. I was constantly running the vehicle, okay, I was constantly on the vehicle. I was moving from point A to point B. Suppose that the distance is 200 kilometers. I haven't stopped and I have completed this 200 kilometers in, for an example, 5 hours, okay. 5 hours, in 5 hours I have completed 200 kilometers. Now for you, what you have done, for every single 50 kilometers you are waiting for, you are taking rest for 30 minutes, 45 minutes, 1 hour. Getting my point? So my average will be better than your average. Why? Because the distance can be fixed. Okay, let us suppose this is a condition where the distance is fixed. You have also covered 200 kilometers, I have also covered 200 kilometers, but the time I have taken only 5 minutes. Now you have taken more than 5 hours. Okay, so that is one of the instant will be there, or event is there. Conditions can be. Moving to next, suppose that I know the road, I know the path, I have traveled. Now suppose that you have to reach to the point B, but by mistake you don't know about the path, you have chosen a different path. Getting my point? Now your total distance is changed, your time is changed, your average will be changed. Okay, that is why it is total distance by total time taken. If someone asks you what is the value or what is the SI unit of this, that is going to be meter per second only. Fine. Now there is one more topic is there, that is known as instantaneous speed. Instantaneous speed means at a particular instant, you are traveling at a particular point. If I ask you that what is your speed, that is called as instantaneous speed. 30 kilometer, 40 kilometer, 50 kilometer, whatever it is, that is that particular moment, that is called as instantaneous speed. I hope it is clear to all. Now if we move forward to our next point, that is going to be velocity, people. The next point is velocity. What do you mean by velocity? So velocity is a type of a speed only. But what is it is change? Why we are not calling velocity as a speed? Why there is a change? See, the change is, in speed, we are totally interested to find out the magnitude. We are not at all interested to find out the direction. But when it comes to the velocity, we are interested in both of them. We are interested in finding out the magnitude, that how fast it is moving, how slow it is moving, as well as we are also interested that in which direction it is moving. Okay, we want that specific direction, everyone. So basically, velocity is called as speed with direction. You can say the velocity is nothing, but it can be said as speed with direction. Sorry, speed with direction. That is what the velocity can be called. Fine. So if it is speed with direction, so every single time we are not saying speed with direction. So we have given a name, a particular name, that is known as velocity, people. Okay. So if we want to find out the formula for the velocity, if we are interested to find out the formula for the velocity, what we are going to write is that velocity is, since it is direction that is there, so we are talking about displacement. Velocity is displacement by time taken. Velocity is displacement by time. If someone asks that what is the SI unit of it, please do remember SI unit is going to be meter per second itself again. And velocity is a vector quantity. Velocity is a vector quantity. Please do remember this. Okay, velocity is a vector quantity. Fine. Now again, as you can see, we are having speed and average speed, so there will be an average velocity part also. Okay. Average velocity part. Average velocity part, everyone. So average velocity, you can write it like this way also. Okay. So generally I like this. So it is V average with an arrow which shows that it is a vector quantity. It is showing that it is a vector quantity. Okay, V average is going to be what? Total displacement by total time. Total displacement by total time. That is known as the formula for the average velocity. Fine. Displacement, Sandeep, I request you to please see the, you can just move back, you can see the backward. Okay, we have gone with the displacement also over here. Okay, what is displacement, what is distance? We have talked about this. You can see the recap, please. Okay. So we have talked about speed, we have talked about velocity. This is the formulas that you have to look forward to. Okay, now if it is done, everyone, at the last we'll talk about acceleration. That is very much important for you. Okay, now what do you mean by acceleration, people? Acceleration. What is acceleration? So the rate of change of velocity. What is acceleration? Rate of change of velocity, people. Rate of change of velocity. Okay, rate of change of velocity is called as acceleration. Now, there are few terms that you didn't understood in this. I totally agree with this. Okay, these are the few terms that you won't be able to understand. First of all, if we talk about rate, what do you mean by rate? The word rate in physics means with respect to time. With respect to time. So we are talking about with respect to time. Velocity you have understood. What do you mean by change? The meaning of change is difference, subtraction, everyone. Okay, the meaning of, I have told you, na Sandeep. You can see the recap. I have already explained you. I have to cover 3 chapters on this. Okay. So you can see the recap. There is no any problem in that. Okay. So when we talk about the rate, rate is what? That is with respect to time. When we talk about change, change means what? That is difference. Difference means subtraction that we are talking about. Okay. So the rate of change of velocity is called as acceleration. That means when the velocity is changing, it may be increasing, it may be decreasing, everyone. Okay. Like first you are moving with 10 meter per second. Now you have changed to 20. Now you have changed to 30, 40, 50, 70, 90. Getting my point? So either it will be increasing, or suppose that you are moving with 100 meter per second, now it is 70, now it is 55, now it is 45, now it is 30. You are decreasing also. So the rate of change of velocity is called as acceleration. This is what it is then. The change in velocity with respect to time. The change in velocity with respect to time is called as acceleration. So if we talk about the acceleration, people, acceleration, A, it is represented by A. Acceleration is change in velocity. Change in velocity means difference, denoted by del V by T. What do you mean by this? It is a difference. Difference means final point velocity minus initial point velocity divided by time. In some of your books, it is written as V minus U by T. That is known as acceleration, where V is the final velocity, U is the initial velocity by time. That is known as your acceleration, everyone. Fine. So please do remember this. This is same thing only. This is same thing. Final velocity minus initial velocity with respect to time. There are few points that you want to remember about the acceleration, people. If we talk about the SI unit of acceleration, SI unit of acceleration, it is going to be meter per second square. Okay. Fine. So as you can see over here, sir, acceleration or velocity may differ. Sandeep, I have just told you that only, na? This is the difference, na? Velocity is what? Velocity is displacement that you have moved from the shorter path divided by time. That is velocity. And if the velocity is changing, suppose that you are riding a bike, okay, riding a bike, scooty, driving car, anything, okay, and it is moving. You are moving with 10. Then you are increasing your velocity to 20, 30, 40, 50 with respect to time. That is known as acceleration. Okay, that is known as acceleration. The SI unit is meter per second, people. The second is, when we talk about the acceleration, the second is, acceleration is a vector quantity. Acceleration is a vector quantity. Acceleration is a vector quantity. Okay. If acceleration is a vector quantity, then we all people know that it can be positive also, it can be negative also. Fine. So what do you mean by positive acceleration, please? Okay. If I want to say it is going to be a positive acceleration, what do you mean by this? Positive acceleration means what? Positive acceleration means if positive acceleration means if what? If your final velocity is greater than your initial velocity, then it is called to be known as positive acceleration. Okay. If your final velocity is greater than your initial velocity, then it is considered to be known as positive acceleration. Or you can simply say acceleration. Or you can simply say acceleration. Simple words. Getting my point? But if we are talking about the negative acceleration, people, what do you mean by negative acceleration is? Negative acceleration, if your final velocity is less than your initial velocity, then it is called as negative acceleration, or you can say retardation. Or you can say retardation. Simple. Or you can say retardation. Okay. If the final velocity okay, I hope this much you people have understood, and this is what it is all about the acceleration. Okay. So when we talk about acceleration is change in velocity with respect to time. And if we talk about positive acceleration and the negative acceleration, positive acceleration, when your final velocity is greater than your initial velocity, it is called as positive acceleration or simple acceleration. Okay. Now, if we talk about negative acceleration means if the body is moving, if the final velocity is less than the initial velocity, then it is considered to be known as negative acceleration. Now, I have given you the example of a positive acceleration, everyone. Now we will be talking about the example of the negative acceleration. How we can say it is a negative acceleration, people? Okay, how we can say what is the example of a negative acceleration, to be very specific. The example for the negative acceleration is like, suppose that you are moving on a bike, okay, and your current velocity is 50 meter per second, and suddenly you have applied the brakes. The moment you have applied the brakes, you people know what is going to be happen. Your velocity is going to be decrease. If your velocity is going to be decrease, in that particular case, if your velocity is going to be decreased, then your initial was 50, your final is going to be 30, 10, 20, whatever, it is going to be decreased only. If it is getting decrement, okay, in that particular case, your acceleration is considered to be known as negative, people. Okay, in that particular case, your acceleration is considered to be known as negative. Fine, that is what positive and the negative acceleration means. Fine. So we have talked about every single thing, positive and negative, and examples also have given you about the idea, and this is what it is. Fine. So we have talked about acceleration, we have talked about positive and negative acceleration, retardation I have talked about. Sometimes it is called as deceleration also. Sometimes the retardation is also called as deceleration. Okay, so please do remember this. Now people, in the motion chapter, there is a huge part of graphs. Fine, there is a huge part of the graphs. Now the thing is, when we are learning about the graph, the graph is actually will be taught you in grade 11. There are two conditions of graph that are being made. First, like for an example, I believe you might have heard about uniform motion. I believe you might have heard about non-uniform motion. Okay, this is things that you have heard about. So these are pre-described, and it is pre-described, that means their graphs are made pre only. Fine, but in grade 11 you will be learning, like there will be a question given to you and you have to find out the graph for that for this particular question, for this given conditions, the body will be moving in which type of which motion. Getting my point? So we are not going to learn the second part, we are going to learn the first part. The graph that I am going to teach you today, it is something extra that you will be there, okay, for grade 9, okay, because it has not been given in your grade 9 books. Fine. Now, if you go with this, people, when we talk about the graphs, please do remember, I want to explain you few things. When we talk about the graphs, when we talk about the graphs, there are few things that is very much important to you, and you should remember that to understand about the graphs, people. To understand about the graphs, it is very much necessary to understand this. When we talk about the graphs, okay, first of all, I believe you know coordinate geometry, but to understand the graph, you should have a basic idea of the coordinate geometry. Otherwise, it will be very tough. Okay, coordinate geometry, everyone. Okay, you should have a very good idea about the coordinate geometry. We are going to make the graph in the first quadrant itself. Okay, we are going to make the graph in the first quadrant itself. Now, please do remember few points. This is going to be an x-axis, as you people know. This is going to be y-axis. This is also you people know. Okay, please remember that x-axis represent the dependent variable, sorry, the independent variable, independent variable. For us, it is going to be time. For now, you can take an example of time. So, as you people can understand, every single time the x-axis will be representing, the time will be represented as x-axis. Please do remember this. Okay, please do remember this, that it will be there. Now moving next. People, the second point is y-axis. Y-axis represents the dependent variable. The dependent variable. What do you mean by this? Dependent variable. When we talk about dependent variable, we can say it is distance, displacement, velocity, acceleration, etc. Okay, so these are something called as dependent variable. So y-axis, okay, so in y-axis represents the dependent variable, whereas the x-axis is going to represent the independent variable, everyone. Okay, fine. So in y-axis it is distance, displacement, velocity, speed, acceleration, whatever it is. Fine. Now, few things, everyone. In the graph, the questions of the graph are coming from the two different segments. What is that? First of all, it is going to be slope, everyone. Okay. Now, the word slope is represented by small m. The word slope is represented by the small m. What is slope is? The mathematical definition I will be giving to you. The mathematical definition is, suppose that there is an inclined surface. Okay, suppose that there is an inclined surface and we are making an angle from the horizontal. The angle between the okay, or you can say the stiffness of a path, the stiffness of the graph is considered to be known as slope. How to find out how much stiffness it is? So we are going to measure it from the horizontal axis, which is represented by theta. Okay, so there are two ways to find out this. If you go with the coordinate geometry way, so m can be called as y2 minus y1 divided by x2 minus x1. Fine. M is equals to y2 minus y1 divided by x2 minus x1. That is going to be your formula for finding out the slope. Or if you know trigonometry, then it is going to be tan theta. If you know trigonometry, then it is going to be tan theta, everyone. Okay. So tan theta will be going to explain you about the slope. I hope this much is clear to all people and you people have understood this much. Check. Now moving next, the slope is done. The second is all about the area under graph, people. It is all about the area under graph. Second is all about the area under graph. So how we are going to understand about the area under graph, people. Okay. So when we talk about the area under graph, it is pretty simple. Okay. So I'm making a rough figure for you. Okay. If the graph look like this, suppose that. If the graph look like this, to find out the area under the graph, okay, basically it is asking about this. Okay, so how to make it? You people will be knowing that it is origin, so the distance from here to here, it is going to be length, and from here to here, it is going to be breadth. Getting my point? So it is going to be length into breadth. The first. Second, if the graph look like this, I'm just giving you the example, the graph may come like this, okay, or may not, but still the procedure will be the same. Suppose that the graph will be look like this. In this particular case, you can see it is a right angle triangle. It is also a right angle triangle. This is a rectangle, everyone. So you can find out the value of half BH, half into base into height, same half into base into height, and it is length into breadth. This is what area will be giving to you. Okay, this is what area is giving to you. Fine. Now, when we talk about the graphs, people, when we talk about the graphs, what are the graphs that we are going to learn? Okay, what are the types of graph that we are going to learn is pretty much important. Okay, what are the graph that we are going to learn? It is pretty much important. So, according to the grade 9 and the grade 10, the graph that we are going to learn, the first is called as position time graph. Position time graph. The second is called as velocity time graph. For grade 9, it is what it is there, velocity time graph. Okay. Now, in position time graph, in the place of position which is represented by the y-axis, okay, replace the position and you can write distance also, displacement also, whatever that you want to write. Okay. So in position time graph, it can gives you the understanding of distance also, distance versus time, and in the position time graph, it will be displacement versus time too. Displacement versus time too. Got it? So now we'll talk about the position time graph, everyone. Let us talk about the position time graph. In position time graph, in position time graph, as you all people know, that the t will be for the x-axis and the y-axis, everyone, it is the positions. For y-axis, it is position, right? So I'm not going to write multiple times. It is, you can understand. If someone is asking about, instead of writing position time graph, if someone says distance time graph, just replace this position from distance. The graph will be same. The meaning is same. Getting my point? Now suppose that if the graph look like this, suppose that if the graphs look like this, what does this particular graph means? What is the meaning of this particular graph? What is happening with the body? So, what is happening with the body? Please do remember, the body will be in rest. This graph shows the body is in rest. How? As you can see, this is position, distance or displacement. So you have reached to 10 kilometers or 20 kilometers. Your time is increasing, but your distance is not increasing. That means you are completely in rest. So this graph shows that the body is in rest. Second, if the graph look like this, then this particular graph shows you about the uniform motion. this graph gives you the understanding of uniform motion. Fine. If the graphs look like this, if the graph look like this, then this is called as non-uniform motion. Non-uniform motion. And one thing, as you can see in this particular arrow, it is going to be increasing. Okay, it is going to be increasing. So, and one thing, as you all know that every single shape has a name. Circle has a name, rectangle has a name. So this curve is also having a name, and this curve is called as parabola. Parabolic curve. And it is increasing, everyone. Please do remember. It is increasing. Fine. If we talk about the other one, for an example, this graph, everyone. This graph. Which type of graph it is? As you can see the arrow over here. It is non-uniform motion graph, but it is decreasing. Which type of graph it is? It is decreasing. Please do remember. Decreasing. Fine. If someone asks about the uniform, it is increasing, right? It is increasing. Uniform decrement, it is like this. It is uniform motion but decreasing. Uniform motion but decrease. It is increase. Please do remember this. Fine. No, it is just a parabola. Simple, no downward, it is parabola only. No downward parabola, it is completely parabola. The curve is parabola. Okay. So I might have not made the curve very specifically to the parabola, but it is parabolic curve only. Okay. Now please do remember this few points, everyone. First, if we talk about the slope, slope of what? First, if we talk about the slope of distance time graph, it will be giving you the idea about speed. The slope of distance time graph will be giving you the idea about speed. The slope of displacement time graph will be giving you the idea about velocity. Okay. And this is what it is there. If we talk about the area under curve, or area under graph, everyone, area under graph, it will be giving you nothing. Please do remember, the answer is nothing. Okay, not for the distance also, not for the displacement time also. Sir, important question for Scrum. So there will be a lot of different sessions will be there. Okay, for 10th also, for 9th also. Multiple sessions will be there. Do not worry. I'll complete every single thing. It may not be completed in one session, but it will be definitely completed before your examination. So do not worry about this. For now, whatever that I'm teaching you, please just go with this, because the question will be asking from this only. Fine. The second one is going to be velocity time graph. Velocity time graph. So if we talk about velocity time graph, everyone, I'm writing for one time only, okay? The time is represented by x-axis, and this y-axis will be representing velocity. Okay, velocity. Now the same thing will be there. Same thing will be happening. Do not worry about this. So same thing will be happening. what is going to happen, people? First of all, if the graph look like this, if the graph look like this, it is now not rest. It is considered to be known as uniform velocity. It is the graph for uniform velocity. Uniform velocity. If the graph look like this, it is a graph for uniform acceleration. It is the graph for uniform acceleration. Fine. Similarly, if the graph look like this, it is uniform retardation. It is uniform retardation. Simple. Okay. If the graph look like this, non-uniform acceleration or non-uniform velocity, whatever that you want to write. And please do remember, it is going to be increase. It is increasing. Second, which type of graph is this? Non-uniform acceleration it is decreasing. Please do remember, if we talk about the slope for the velocity time graph, the slope of velocity time graph will be giving you the idea about acceleration. Okay, and area under graph will be giving you the idea about displacement. Giving you the idea about displacement. Please do remember this. The area under graph will be giving you the idea about the displacement. Okay, fine. The last topic, everyone, that is equation of motion. Please do remember this, equation of motion. Equation of motion. There are three equations of motion, everyone. The first equation of motion is considered to be known as V will be equals to U plus AT. The second equation of motion is S equals to UT plus half AT square. The third equation of motion is V square minus U square equals to 2AS. Now where people, V is the final velocity, V is the final velocity, U is the initial velocity, A is the acceleration. I believe you all people know this. T is time. And S can be used in different conditions, everyone. S can be written as distance also. S can be considered as distance also, displacement also. Sometimes it is considered to be known as height, and sometimes it is considered to be known as depth. It totally depends on question to question that what we are trying to find out. The SI unit is going to be meter per second, initial final acceleration is meter per second square, time is second, and it is going to be meter. Fine. So these are the three equations of motion that you have to remember. That is first equation of motion, second equation of motion, third equation of motion, and these are the values that you have to remember. Fine. This is what it is there. I hope this much is clear to you and you have understood this much. This is the theory, basic theory that you required for the, what do you say? This is the basic theory that you required for the motion chapter, everyone. This is the basic theory that you will be requiring for the motion chapter. Now, if you go with the question, people, if you go with the question says, first question, the displacement time graph of two particles A and B displacement time graph is given, okay, are straight line inclined an angle of 30 degree and 60 degree with the time axis, okay. The ratio of their velocity will be what? So how to solve this thing? People know that when we talk about the slope of the displacement time graph, the slope of displacement time graph gives you the understanding of velocity. So velocity of A will be equals to represented by tan theta. Tan theta A. Why? Because I have told you about the slope. The velocity of B will be represented as tan theta B. And we have to find out what? We have to find out the velocities. That means we have to find out the ratio of velocity A and velocity B. So in that particular case, the velocity A by velocity B, everyone, 10, how much? That is 30 degree, people. So 10, 30 degree. If you know trigonometry, then it is going to help you out. If you don't know trigonometry, you have to learn trigonometry then. Okay, that is going to be 60, people. Okay, now I want you all to, if you people know about the trigonometry and all, just find it out. Just find it out, please. Just find it out. 1030 and 1060. What is going to be the answer? 1030 and 1060. What is going to be the answer? If you go for the 1030, people, velocity of A by velocity of B. Sorry. Velocity of A by velocity of B. 1030 is going to be 1 by root 3. 1060 is going to be root 3. If you solve this thing, VA by BB will be equals to 1 by root 3 multiplication of root 3. That means VA by BB is equals to 1 by 3. Or we people can write that the VA is to VB will be equals to 1 is to 3. That will be your answer. Fine. That will be your answer. I hope it is clear to all people and you have understood this much. Okay. This is how you can solve it. Fine. That is D, everyone. And suppose that it is going to be 45, then it is going to be 1. If it is going to be 1 over here, then it is 1 by root 3. Simple. Okay. So we have one more question, people. Let you try, because you have gone with the chapter. Okay, I have given you the information of all of the things. I request you all to please just find out the answer, what you feel that the correct answer will be. As you can see the question says, a 150 meter long train is moving with uniform velocity of 45 km per hour. The train takes by the time taken by the train to cross a bridge of length 850 meter is. Yes. Now, how to solve this question? Basically, it is going to be a very basic question. First of all, as you can see, there are few things that you have to go through with this. That first of all, you have to understand that it is this value is given in meter, this value is given in kilometer per hour, and this value is given in meters. So you have to convert the kilometer per hour into meter, or you have to convert. Nahi, nothing can be done. It is tan theta only. Okay, so either you convert meter into kilometer, or you can convert kilometer into meter. So the shortcut will be, the solution for this, as we have the formula, as we have the value of the velocity, that is 45 kilometer per hour, which can be converted into meter per second if you just simply multiply it by 5 by 18. Okay, simply multiply it by 5 by 18. This is 3 times, that is going to be 15, sorry. 15. 3 times, it is going to be 6. 6 is 18. Again 3, 3 2s are, 3 5s are. Okay. Now you will be getting the velocity in meter per second is 5 5 25. 25 divided by 2, that is going to be 12.5 meter per second. 12.5 meter per second, it is going to be the answer. Fine. For the velocity conversion, we have 150 meter long train and the bridge is 850. So what will be the total distance? Total distance will be what? That is 150 for the train plus 850 for the bridge, for covering, for completely crossing. It is going to be 1000 meters. What we have to find? We have to find out the time taken. We all people know the very simple and basic formula that we all know, that distance is equals to speed into time. We have to find out the time, that is going to be distance by speed. We know distance, that is going to be 1000. We know speed, that is going to be 12.5. Solve it. Solve it, people. Since I have the liberty of this, I will be using this. Hai na? It is going to be 80, everyone. 80 seconds is your answer. I hope it is clear to you. The 80 seconds is going to be your answer. Fine. 80 seconds, fantastic. Okay, very good, people. So these are the few types of question that may be asked you in your score examination. There are many more. And we will be doing a lot of different examples. Do not worry. I will be teaching you every single chapter that is mentioned in your syllabus, and we will be doing a lot of different questions and answers also. Okay, so just be relaxed, be attentive in your this particular sessions. Okay, whenever that is going to be happen, subscribe the channel, everyone, and this is what it will be there. Every single chapter will be covered, every single type of question will be covered. So just relax, okay, and be attentive on the class. The only thing that is required from your side is be regular, be true to what you are doing, okay, and be attentive on the class. That's it. If you do like this, believe me, the score examination is nothing. You will be very much capable of giving the any question and answer related to the grade 9, grade 10 physics. No. It is this score, entire thing, the score of entire thing will be given in the Sri Chaitanya channel. Okay, not the Infinity one. Fine. Chalo. Thank you everyone for joining the session. There are many more things that we will be doing, hai na? Do not forget to register for the examination, and the date is 28 September to 12 October, everyone. Okay, and do like, comment, share, and subscribe the channel, everyone. Okay, and you can follow us on Instagram also, Telegram also. The PDF of this thing will be given into the Telegram channel. You can subscribe the channel. Facebook is also there. Fine. This is all for the day. Thank you everyone for joining. Bye everyone. Take care. Have a nice day. And please be attentive in this particular session. Every single thing will be done. Thank you. Thank you everyone. Bye. See you all.